let me tell you a little bit about the different kinds of regulators. I have basically two types here. There's a bunch of different ones here, but there's basically two types here. Okay, this kind right here, Bourdon gauge, I think it's called. Okay, if you look at these the way it hooks up, can you tell that this is to hook into a wall mount oxygen supply? So this occurs in a clinic or in a hospital, in a clinical setting, okay, where you have a master oxygen supply to a building, and you just stab these into the oxygen port, and you turn it on. Here's your dosing meter, and it's 0, 1, 2, 3, 4, 5, and liters per minute goes up here. And there's a little metal ball. I don't know if you can kind of see it there. But as you turn it higher, that little ball will rise, and whatever mark it's on, that's your dose in liters per minute. And then, of course, this is your Christmas tree. The oxygen comes out of here and goes to your patient. Same Christmas tree as this one. The oxygen comes out of here, oxygen comes out of here, but this hooks into a wall. So this will not hook onto this. They don't mate up. They're not designed for each other. This is for inside of a hospital in a nice controlled environment. Okay. And of course, you couldn't lay this down, because if it was laid down like this and it was all the way here, how could you tell how much oxygen is coming out? It wouldn't. You don't hook it upside down. You hook it right side up with the tree down. Does that make sense? That way you can read it. So this goes on a wall. Everything else here, if you look at the yoke, they're all the same. These are all different versions of the same thing. The yokes are designed to hook into the neck of a tank, just like this one. So these three are pretty similar. They have single gauges. They have a dosing wheel in liters per minute. They got the tightening wheel over here. They got the safety, the pins right here, and then they have the big one where the oxygen comes out of the tank and goes into the regulator and gets stepped down. This one is the same thing. This is a little bit older model of this. This is kind of a modern regulator that we would use in EMS, or it's portable, or we would take it into a room and lay it down. Yes, ma'am?
What is the cost of the modern one?
I think to buy these, it can be, because you can get them with a lot of doohickeys on them, with a lot of extra ports and things like that, but a stripped down base model is going to be something in the like $400 range, $500 range, but they can go up to like $800, depending on how fancy you get it, with rubber coating and fancy colors and stuff like that. But so yeah, just this little piece right here is expensive. This is an older one. It does the same thing, but when you hook it into the tank, okay, this would hook into the tank this way, and when you hook it in, you have two gauges. But if you look, one of them is graduated real high in PSI, and one of them is graduated, if you look at it, in LPM, liters per minute. So this is to turn it on. This is the same as the dosing wheel. This wheel right here is the same as this wheel right here. And the numbers right here, your liter flow per minute here, is the same as these numbers on the left gauge, because this is closer to the Christmas tree, this is closer to the patient, this is reading what's going to the patient. This one, the bigger one and higher numbers, is reading what's inside the tank. So I've got two gauges right here to look at. It's just got more plumbing and more parts and stuff. And you don't really, you can still find stuff like this, because these things are robust. They're chunks of metal. And they have some moving parts in them and stuff, but not very, so they'll last a very long time. So it's totally conceivable that you would see a regulator like this. You would encounter that in your career, absolutely. So that's the only difference. So if you want, I'm going to hook this one up just because it's a strange one, different to this, and show everybody. So I'm going to shut this off. Actually, you guys tell me what to do. Shut it off. There's pressure in here.
Let the pressure out.
Let the pressure out. How do I do that?
Turn the knob just.
Turn the knob just a little bit? Okay. Good. Now what do I do? Turn this off?
Close it off.
Close it.
And then.
Now it's safe to take this off?
Yes.
Good, okay. Good deal. So now I'm going to take this one. Same thing, pin in it. Am I missing anything?
Yes, the little thing.
The seal, the little doohickey. Yeah. Okay. A little steel put the doohickey in here. Same setup. Alignment pins with alignment holes. Okay, tighten it up just like before. Okay, make sure this is open. Now I need to open my tank, right? Turn it in a safe direction so it's not pointing in anybody's face. Righty-tighty or lefty-loosey? Lefty-loosey, okay. I'll turn it on. Now, ooh, where's my glasses? Thank you. If you look here, I have pressure. I'm down to like 400 or 500 now, right? This is my liter flow, liters per minute of oxygen. All I have to do, remember this is the same as the dosing wheel. If I turn this, listen to the Christmas tree. So I've got it set to 4 liters per minute right now coming out of the Christmas tree. I just have 2 gauges instead of 1. Lucy turns it off. So if I want to take this off, what do I got to do first?
You have to turn off the air.
Kill the tank. Righty-tighty or lefty-loosey?
Righty-tighty.
Righty-tighty. Okay. Now I still have pressure in here. What do I got to do?
Let it bleed out.
Bleed it out. Pressure's gone. And then what do I do? Now is it safe to take this off?
Yes.
Okay, unhook it, untighten it here. Take it off. Same thing. All right, so I'm gonna hook this back up real quick. Let's get into some actual delivery devices. What's that? Leak? Check my seal. Do that. Tighten it up. There you go. I'm going to lay this down just to be safe. So now let's talk about actually delivering oxygen to a patient.